Today's lesson is Law of Exponents by not using our calculator. So what is my learning objective? My learning objective is I can rewrite expressions involving rational exponents without a calculator by applying the properties of exponents. So my basic equation is y equals any base to the power x, and I should know at least the first four for base 2, base 3, base 4, and base 5 very easily. Or when I'm I'm working through my assignments, I make a small chart with these so I can see them while I'm simplifying. That kind of makes my life easier. Okay, I also have the basic rules of exponents here. I have the name of the rule, and a numerical example. These are all expected to be memorized. None of these are given on the SAT test. Okay, so these are how I manipulate and work with equations without referencing a chart. I should be working from these from memory. All right, so let's do some examples. So number 1, evaluate -1 to the 12th. So this is really -1 times -1 times -1, and on 12 times. So I should be looking at, I'm raising a negative number to an even power. So an even number of negative signs is a positive. So my answer is 1. Number 2, my negative sign is not in the parentheses. So this is really -1 times 3 times 3 times 3 times 3. So 3 to the 4th I should kind of have memorized. So 3 times 3 is 9 times 9 times -1. So my answer is -81. All right, number 3. When I'm raised to a negative power, I can flip my fraction. So this is 3/2 to make my exponent positive. Now I can evaluate 3 cubed is 27 and 2 cubed is 8. 5 to the 0 power is 1. Anything raised to the 0 is 1, except 0, which is undefined. All right, let's look at number 5. 5 times 5 squared. I am going to add my exponents, so this is 5 cubed. 5 cubed is one of those that we should have memorized. 5 times 5 is 25, times 5 is 125. Number 6. When I have a bunch of different bases, my goal is I want to rewrite to the same base. Okay, so rewrite to the same base. So which base do I choose? I want to look at the smallest base that I have available. So I look at the smallest base. And if I can rewrite in terms of the smallest base of what was given, if it doesn't work, then I go smaller. So in order to get everything into the same base, right, in this example, I cannot rewrite everything in base 8. So I'm going to go down to base 2, which is smaller. So I'm thinking of 8 as 2 cubed. So this is 2 cubed raised to the 3rd power. 64 is 2 to the 6th to the -1 power. And 16 is 2 to the 4th squared. So now I am exponent to exponent, so I multiply. So 2 cubed is really 2 to the 9th. 6 times -1, so this is 2 to the -6th power. And 4 times 2 is 8, so this is 2 to the 8th. All right, so next, when I am multiplying with the same base, I add my exponents. So 9 plus -6 is 3. So 2 cubed divided by 2 to the 8th. And I always want to put my exponent in the positive position, so I'm going to put it in the denominator. So 8 minus 3 is 2 to the 5th. And 2 to the 5th is 1 over 32. All right, let's try some more. Use the laws of exponents to simplify. So my cubing is on the outside, so that applies to everything inside. So I'm going to rewrite first. So this is -3 quantity cubed times x cubed, and 6 times 3 is 18, so y to the 18th. -3 cubed is -27, x cubed, y to the 18th. Okay, so my number 8, I see I have the same base. So when I have the same base, then that means I add my exponents. Okay, so this is a to the x plus 3 plus x minus 3. So plus 3 and minus 3 total 0, so I'm left with a to the 2x. X plus x is 2x. Let's try 9 and 10. I'm going to multiply coefficient times coefficient. So 3 times 4 is 12. And then I'm going to add my exponents because I'm multiplying. So 1 plus 3 is 4. So 12a to the 4th. All right, I'm doing exponents. Or I'm going to work with coefficients, then I'm going to work with the same bases. So starting out with my coefficients, 27 and 45 are both divisible by 9. So 27 divided by 9 is 3, and 45 divided by 9 is 5. So I start out with 3 divided by 5. Next, I'm going to look of base A. So I want to be where I have a positive exponent, so that'll be in the denominator. So I'm going to say 4 minus 3 is 1, so I'm left with a to the first power in the denominator. I do not have any other base b's, so that just stays in the numerator as is, so b cubed. And then my base of c will be in the numerator, so 5 minus 2 is 3, so c cubed. Okay, so juniors, what does this look like on the SAT? I have pulled 2 SAT release questions that are associated with this. So these come from a no calculator test under the section called Passport to Advanced Math. All right, so it's a time test, so I don't have time to work these all out. This is checking, do I understand the skills? So I'm going to do what I said before, is if I have 2 different bases, I want to rewrite in terms of the same base. So 8 is another way of writing 2 cubed. So 2 cubed to the x power. divided by 2 to the y power. And then next, I can subtract, since I have the same, so I'm sorry. Next, I'm going to multiply 3 times x, so I get 2 to the 3x divided by 2 to the y. Now I can subtract my exponents. So 2 to the 3x minus y. And I see I have 3x minus y, and that's what I have in my exponents. So I know this is equal to 2 to the 12th. Okay, so I'm recognizing this from the question. So it is asking me, what is the value of this? Well, the value is 2 to the 12th. Okay, next question. A to the x squared divided by b raised to the power x raised to the power b squared equals x to the 16th. So again, I'm always trying to get in the same kind of base. So I am looking at this as I'm going to separate raising these powers to powers. So I'm going to look at this as x to the a squared divided by x to the power b squared. And since my left side of the equation is squared, I want to do the same thing with the right side. So this is going to be 8 squared, x to the 8th power squared. So now I want to undo my squaring with my inverse function of square root. Whatever I do on the left side, if I do it to the right side, I kept my equation equal. So now this is x to the a divided by x to the b equals x to the 8th. So on the left side, I can subtract my exponents. So this is going to be x to the a minus b equals x to the 8th. So right now what I see is my bases are equal. So that means my exponents are equal. Oops. So the question is asking me what's the value of a minus b, and a minus b is 8.